Holy moly, that's 11.7 watts, baby. Get some. Hi there everyone. In this video, we are going to be taking a look at and testing a couple of new VTXs from GEPRC. These are the Maten 1.6 and 2.5 watt VTXs. And in this video, I'm going to be taking you through all of the key features of these VTXs on the bench. And then we are going to be testing them using my VTX power output meter to see how they compare up against their ratings. It's a lot to cover in one video. Let's not waste any more time. Let's dive right into it. If you've been following the channel recently, you might have seen that I'm wearing some awesome new drone-themed t-shirts. I've been working with an amazing designer to create some bold, bright graphics capturing my favorite moments in FPV. Right now we're launching 4 designs: the Drift Chase, Mid-Air Motocross, One Pack Bando Rip, and the Mountain Dive. You can get these graphics as a high-quality print on a t-shirt or jumper like I'm wearing, or you can get them as a tote bag, notebook, sticker, or a face mask. Check out the links down in the video description. The VTX comes in this nice plastic box, and it comes with a load of accessories. You get this wiring harness to connect the VTX to your flight controller nice and easily. You've got a right-angled MMCX whip-style antenna and a right-angled MMCX to SMA adapter. You get a bag of M3 mounting hardware. There are some plastic standoffs in here, some spacers, and some M3 metal screws. You get a really nice detailed instruction manual, and we're going to be going through that in just a second, and you get the VTX itself. Looking at the VTX itself, it's fully enclosed in this black anodized aluminium heat spreader with 30 by 30 M3 mounting holes all the way around the outside. We also have 2 20 by 20 mounting holes here, diagonally spaced, and these are threaded to M1.6, so a little smaller than the standard for a 20 by 20. Around the outside, we've got the JST 1.0 plug for the wiring harness. We have the MMCX output connector, and we have 3 LEDs and a push button. The LEDs indicate power, band, and channel, and this key allows you to change between the settings manually. On the back of the VTX, we've got a ton of silkscreen indicating the maximum power, reminding you to install the antenna before you power on the VTX, very important, and giving you the wiring for the wiring loom, so the pinout for it, and also detailing the channel band and power lights on the side as well. The 2.5 watt VTX is physically identical to the 1.6 watt VTX, and it is connected just the same, and it works pretty much the same. The only difference is that the 2.5 watt VTX has an extra power setting for a higher output power, and the 1.6 watt VTX doesn't. So I think the only difference between these two parts is likely to be in firmware, and it's just whether or not you have access to that 2.5 watt power setting. The specs on this VTX are really, really good. We've got up to an 8S input voltage. It's got an inbuilt 5 volt BEC that supplies up to 600 milliamps for powering a camera or something like that. It supports up to 72 channels across 9 different bands, and it can be controlled over the IRC tramp protocol from your Betaflight VTX. Overall, the VTX itself weighs 18 grams. The instruction manual for the VTX is also excellent. It gives you a wiring diagram. It tells you how to set up your ports in Betaflight. We've got the frequency table showing you all the bands and channels that it supports, and how to download the VTX table to apply it to Betaflight. Now, I couldn't actually find the VTX table following this link, but it is available just if you go and search on Betaflight, and I'll put a link down in the video description. You can tune the VTX, obviously using the Betaflight OSD, but if you want to use the buttons, you can also use the buttons to adjust channel band and power, and there's a pretty intuitive method for clicking through to select different channel, band, and power settings. Looking through the specs and features, there is really nothing that I was able to find fault with on this VTX. It's got all of the features that you would expect from a top-of-the-line analog VTX, and particularly the huge range of channels and bands that it supports is really excellent. Although you are going to need to be careful because it may support channels and bands that are not legal in your region. So make sure to check what bands you're allowed to use and to adjust your VTX tables in Betaflight so that you don't accidentally use frequencies that are outside what's legal in your country. Now that we've looked at the specs and features, it's time to dive into the power output testing and see if these VTXs live up to their 1.6 and 2.5 watt ratings. So this is the test setup we're going to be using to measure the RF output power of this VTX. We're using the analog device's ADL5902 True RMS power meter, and that's connected to the VTX through 40 decibels of attenuation. This brings the output signal from the VTX down into the measurement range of this meter. The meter converts the RF input power into an analog output voltage signal, which is measured by the Arduino and run through a calibration curve to take into account the 40 decibels of attenuation, as well as the internal calibration of this device. That is displayed here on the screen as a milliwatt output power, and it's also transmitted over serial to the PC for logging. We've got the VTX connected to a Betaflight flight controller for remote control of the channel, band and power, and the VTX is being driven off a power supply set to 12 volts, although I have verified that changing the input voltage doesn't change the output power of this VTX at all. The VTX is kept cool by this little fan here, which is just blowing air over the VTX to keep it at a constant temperature throughout the testing. All right, now we've taken a look at the test setup, it's time to dive into the results. And my goodness, you never know what you're going to find until you start looking. All right, let's start by taking a look at the VTX power output of the 1.6 watt Maten VTX. And what we're looking at here is a chart of VTX output power versus frequency. And I've tested these VTXs at 16 different frequencies, the entire low race band from 5362 megahertz up to 5621 megahertz, and then race band 5658 megahertz all the way up to 5917 megahertz. So we're covering the maximum possible range of frequency that you can operate this VTX over. Obviously bear in mind that not all frequencies are legal in all regions. At 25 milliwatts, we get a really interesting shape to the power output curve with frequency, where the power output starts off really low at about 60 milliwatts at low race 1, and as we move up the frequency, the power output increases, and around low race 8 and race band 1, we're getting around 650 milliwatts or something from the VTX. So much more than its rated 25 milliwatts of output. And then the power output comes down as we move higher in the race band frequencies. So by the time we get up to race band 8, we're back down to about 90 milliwatts of output power. So this VTX delivers a lot more than its rated output on 25 milliwatts. If we go up to 200 milliwatts, we see a much flatter power output with frequency curve. At low race 1, we're at 563 milliwatts, and that increases up a little bit. And at race band 1, we're at about 694. And then as we come down towards race 8, the power output drops a little bit to about 295 milliwatts. So it's closer to its 200 milliwatt rating, but still quite a lot of variability, and it's definitely more powerful at those lower frequencies. Moving up to 600 milliwatts, same story. Actually, we get very flat power response in the low race band, but the power output is really high. In this particular sample, and there will be variability between VTXs, quite a lot of variability I predict, we're getting anywhere from 1.6 watts at low race 1, and then at race band 1 it's still 1.6 watts, and then it decreases towards race 8, and we're getting about 650 milliwatts on race 8. So again, big variability depending on frequency, and overall the VTX is always delivering more than its rated output power. Then we get to the 1.6 watt setting, and I mean, the power output is crazy. I mean, we're talking about 4.4 watts on low race 1, decreasing down to about 3.7 watts at race band 1, and dropping further down to just about 2 watts on race band 8. So I don't know how much variability there's going to be between different samples. I may have just got a particularly powerful VTX, and that can happen for a whole host of reasons to do with the tuning of the oscillators and the amplifiers in the VTX itself. But this VTX is delivering quite a bit more than 1.6 watts. What we should say at this point is that it's actually not too surprising to see such a huge range of power outputs when looking at the results in milliwatts. RF power output is normally measured in dBm, decibels, that's a logarithmic scale, and a variability of plus or minus 3 or even plus or minus 6 dB is pretty common. 6 dB is a 4 times change in power output. So if you go from 1 watt to 4 watts, that's taking you from 30 dBm to 36 dBm. So Actually, in terms of decibels, changing from, let's say, 4.4 to 1.6 watts, I mean, that's only about 3 dB or so, a bit more than 3 dB, which is pretty typical for a VTX like this. And the reason I'm saying that now is that we're about to look at the 2.5 watt version. The 2.5 watt version of this Maten VTX is totally bonkers. And I mean, we should say up front that this is kind of under ideal conditions because the VTX has got ideal cooling, but still the power output is insane. We get very similar numbers to the 1.6 watt VTX for all of the low power modes, exactly as we would expect. And this is why I think it's only a firmware difference between these two VTXs. It's not actually any hardware difference because we get very similar power output and a very similar behavior in terms of power output from both the 1.6 and the 2.5 watt versions. But obviously it has this extra setting, the 2.5 watt setting. And I mean, the power output, race band 8, where it delivers the least amount of power, it's delivering 2.4 watts. Come up to race band 1, that power increases to 4.9 watts. And I measured this thing at 11.1 watts continuous output power on low race 1. And it was totally happy. It sat there on my bench. It was pulling 15, 16, 17, 18 watts from the power supply and delivering 11 watts RF output and getting really freaking hot. But yeah, the fan was on it and it just kept putting out that power. It didn't sort of ramp down or limit in any way if the fan was blowing directly on it. So yeah, I'm really impressed with the amount of RF output that these GEPRC Maten VTXs are able to offer under ideal conditions when you've got plenty of cooling. So now that you've seen the bonkers output power, it's time for me to make you aware of a couple of weird quirks I've noticed with this VTX that are definitely worth you being aware of. So the first quirk to be aware of has to do with the VTX power levels. If you are, let's say, at 25 milliwatts on channel 1, and we can see that the VTX is outputting about 175 milliwatts. If I increase to, let's say, 1.6 watts and hit save, that won't actually trigger the VTX to change power. You can see the VTX is still 175 milliwatts or so. If, however, I change the channel, then that triggers the VTX to change both its channel and the power setting. So you can see the power has jumped up to, well, just about 1.5 watts. If we go back down to channel 1 and then we change down just to 25 milliwatts, so we're just changing the power setting now, that will usually work. So going down in power usually works, going up doesn't. What this means is if you're using a remote control from Betaflight, you're probably going to need to change the channel as well as the power to make sure that setting change sticks. And if you just change the power level, you won't know necessarily whether the power level has actually changed, and it may not have done. So make sure you might have to just go up one channel and then down one channel just to kind of cycle that and get it to accept the new power setting. The second strange bug that I noticed is that occasionally the VTX will just jump to its maximum power output for a second or two and then drop back to the power output it's been set to. This seems to happen somewhat randomly and it only lasts for a few seconds, but obviously it might cause issues if the VTX is close and you might knock someone else out of the air because you suddenly jump up to a much higher power level than what you were at before and you cause interference and they can't fly anymore. So that's just something to be aware of as well. As far as I can tell, both of these bugs only affect the 2.5 watt version of the VTX. I couldn't get either bug to reproduce on the 1.6 watt VTX. If you're interested in picking up either of these VTXs for your next build, then there are links down in the video description. And if you click through on those links and make any purchase, the retailer will make a small donation to support the channel on your behalf. This comes out of their profit share and it doesn't cost you anything. It's completely free for you. So I'd really appreciate it if you would use those links if you're able to and help support the channel, help me make more videos like this for all of you. I really hope you enjoyed the video. I hope you found all the information fascinating and I can't wait to see you in the next one. Until then, happy flying.